Jai Bharat to all students. In last lecture, we have discussed about revision of our previous semester, vector and matrix. Okay, so it will be required to study vector and matrix in our next chapter. But first of all, let me start with your subject introduction and introduction to graph. Okay, then we will discuss about matrix and matrix in graph. Okay, so first of all, let me start with the graph theory. What is graph? Here in this lecture we will see a number of different definition. Okay, so try to remember it, and for this definition we will useful in our next chapter also. Okay. Okay, now we will start with the what is graph. Okay, first of all, what is graph? Okay, here we have two figure. One is rod netter. This is a rod netter of PQ RST, and this is a electrical circuit. Okay, electric network resistance. Okay, so now either of this situation can be represented diagrammatically by means of points and line. By means of points and line. Okay, so here for P, Q, R, S, T are called vertices. Okay, in our next and all the next chapter we will tell this point as a vertices. Okay, and the lines are called edges. This line, that this line, this line, this line, this line, and this line also here, this line. Okay, all the lines are called edges. So vertices and edges, and wall diagram is called graph. So this is a definition of graph. Okay, now intersection of PS and QT. PS and QT, here PS and QT also. This is not a vertices. Why? Because here you can see that they have not interconnected. Okay, does not correspond to the crossroad or meeting of the two wire. Okay, yes. So this is for this meeting point, it's not called vertices. Okay, vertices are only 5: P, Q, R, S, and T. Okay, and now next definition is the degree of vertex is the number of edges with that vertex as an endpoint. Okay, what this will say, that degree of vertex is the number of, we have to count the number of edges with that vertex as an endpoint, Okay, so let me start with figure first. This figure, rod network. Okay, here P is connected with how many edges? This is one edges, this is also one edges, and this is one edge, three edges. Okay, so here we have to count number of edges. So P have connected with three edges. So degree of vertex of P is 3. Yes, degree of vertex for P is 3. Now calculate for the Q. Q, how many edges are connected with Q? 1 edges, 2 edges, 3 edges, and 4 edges. Q is connected with 4 edges. So degree of vertex is Q, for the Q is 4. R have 2 edges, so 2. Degree of vertex is 2. S is connected with also have 4. T is connected with 3, and P is connected with 3 edges. So degree of vertex for particular P is 3. Degree of vertex for Q is 4. Degree of vertex for T is 3. Degree of vertex for S is 4, and degree of vertex for R is 2. Okay, so we have discussed in this point 4 definition: vertices, edges, wall diagram is called graph, and degree of vertex. Okay, now this point of two graph also we can represent like this. This is the same graph, but not with the road network and electric network. Okay, PQ RST. Okay, so point 3, this figure is also represented others way. For example, if PQRST represent football team, these football teams, then existence of the edge might corresponding to the playing of game between the teams at its endpoint. Okay, now here this graph represent road network, this graph represent electric network, and let's say this graph represent football team. Okay, so for P football team, they have to compete with the Q, T and S. They have to play the match between Q, T and S, and for the T football match they have to compete with P, Q and S. For the S they have to compete with 4 teams, T, P, Q and R. Okay, so playing football between the team at thus in figure point 3, team P has played against team QST. Okay, yes, P has played against QST but not against team R. Okay, so in this represented, the degree of vertex is the number of games played by the, in this represent the degree of vertex is the number of games played by the team. Okay, so P have played with 3 teams, though we have number of vertex is 3. Q has played with 4 teams, 4 vertex, degree of vertex 4. S also degree of vertex of 4. R has played with 2 teams and 3. Here now you can see that all 3 of this graph degree of vertex is same, representation is also same. Okay, so now next graph. Another way of depicting this situation to use the graph in figure point 4, this figure, that we have removed the crossing of line PS and QT. We have removed the line crossing line of PS and QT. Okay, we have made different route. Okay, so the resulting graph still tell us whether there is a direct road from one intersection to another. Okay, so how electric network is wire up. Okay, same graph, this is also a same graph, all the 4 graph are the same. Yes, we can still move from P to S, we can still go from P to Q, we can still go from P to T. Okay, so now in this only information we have lost concern is metrical properties such as length of rod or straightness of wire. Okay, wire here wire is not straight or length is not relevant. Okay, but the graph is the representation of set of point and how they are joined. Okay, any metrical property are irrelevant. Okay, so we are what they are trying to set, if this joint is connected with like this P and Q, still this represented the same graph. Okay, graph is only represented of set of point and how they are joined with the other vertex. Okay, not relevant to how straightness they have joined or bigger path they have created. Okay, so any metrical property are irrelevant. Okay, so these 4 graph are all the same. This graph, these 2 graph, road and electric network, football team, and this graph is all the graph are the same. Okay, so generally we can say that 2 graphs are the same if 2 vertices are joined by edge in one graph, if and only if corresponding vertices are joined by edge in the another. Okay, what they say that if in two graph, if this same 2 vertices, here P and here also P, are joined by edge. Okay, joined by edge. Okay, here they have joined by PQ edge, P and T edge, and P and S edge. Yes, how many edges are joined with P? This is one edge, second edge, and third edge. PQ edge, PS edge, and PT edge. Okay, here also, what is the edge of P? Vertex is P, PQ edge, PT edge, and PS edge. Okay, so both the graph have, if one vertex is corresponding to that edge is same, so we can say that these two graphs are same. Okay, so here in figure this, all idea of space and distance have gone, but we can still tell a glance at which points are joined by a rod or wire. Okay, here also they have given another graph. Okay, here you can see that P is connected with Q, T, and S. Here also P is connected with Q, T, S. T is connected with P, Q, and S. P, Q, and S. T connected. Q is connected with P, S, T, and R. P, S, T, and R. Okay, so here all the space and distance between them are gone, but we can still tell them that which points are joined by a rod or a wire. Okay, so this is also a same graph. Okay, so here we have discussed five different figure that has a it represented the same graph. Okay, so it does not depend on the distance between them, space between them, or straight, it's either straight or not. Okay, so this is all are the same graph. Okay, now let's say with the next definition. Okay, now here we can say that roads joining Q, S, and S and T. Here Q, S, and S and T have too much traffic to carry. Okay, let's say this is a road network, so we can say that this road and this road have too much, because why? They have coming from the 4 road. Okay, so let's say they have too much to traffic. So okay, so we can ease the situation by building extra road. We can build extra road joining this point. Okay, so resultant diagram look like this. Okay, we have make the 2 roads or 3 roads, okay, for same point. Okay, so this is called multiple edge. Okay, this is called multiple edge. They have multiple edge. This is only one edge, but they have here, they have 3 edges, and they here Q and S point we have 2 edges. So this is called multiple edges. Okay, so the edge joining Q and S or S and T are called multiple edges. Okay, now if in addition we need a car parking here, point P, if we need a car parking, then we indicate this by drawing an edge from P to itself. It's called loop. Okay, here in figure you can see that we have make the car parking for the this point. Okay, so we can say that drawing an edge from P to itself is called loop. Okay, we have started with P and ending with the P. Okay, small road. Okay, we also called, it's called loop. Okay, so we have see another 2 definition, multiple edges and loop. Okay, so now in the next lecture we also discuss contain many loops and multiple edges. Okay, now graph with no loops or multiple edges such are called the simple graph. As we see earlier, this is called simple graph. Okay, in which they have not any loop or multiple edges are there. Okay, this is called simple graph. Again some definition, simple graph. Now our next definition is directed graph. Okay, the study of directed graph, or you can say diagraphs, as we abbreviate from them, arises from making the roads into one-way street. Okay, directed graph is said that making roads into one-way street. Okay, like this figure. Okay, we can only go from P to Q, not from Q to P. Okay, it is only a one way road. Okay, if we want to create two-way road, we have to create again a new edge. Yes, new road. Okay, but this is only one way from the road. You can see that one way. Here from Q and S they have two lane road. Okay, so we can grow from S to Q and Q to S also. Okay, so this is the directed graph that only a one way street. Okay, this is called directed graph. Okay, so with the direction of one way street indicated by arrow, such director is also called an arc. Okay, this is called edge, and this is for arrow representing the on edge is called arc. Okay, in this example they have discussed that at T point all the traffic are merging. All the traffic are merging at T point. So we can at T are there traffic or chaos, but that not we have to study them. Okay, and study such situation. Okay, so this graph is called directed graph, one way street. We have to convert this into one way street. Simple graph and directed graph, multiple edges and loop, then vertices, edges, graph and degree of vertex. Okay, these are the definition we have studied. Okay, next definition. Much of the graph theory is devoted to a walks of various kind. Okay, walks. Again, new definition. A walk is a way of getting from one vertex to another. Walk is the way of getting from one vertex to another in a graph or digraph. Okay, this is digraph and this is a simple graph, and consists of sequence of edges or arc. Okay, this is called arc and this is called edges. Simple graph edges and digraph it's called arc. Okay, let's say example this figure PQR. P, Q and R. This is called what is called walk with two length. Why two length? Because we have crossed 1 and 2 edges. Okay, so this is walk of two length. Okay, we have traveled from P to R. Okay, yes, PQR is a walk of length of 2, and again they have said PSQ TSR. Sorry, P, S, Q, T, S and R. Yes, see this is also a pass, and how many length? Okay, this is a multiple edge. Try to P, S, Q, T, S, R. Okay, so how many edges we have crossed? 1, 2, 3, 4 and 5. So this is a walk of 5 length. Yes, we have gone from P to R, but we have decided to stop from the Q and T also. So P, S, Q, T, S, R is also a walk of 5 length. Okay, P, S, Q, T, S, R is a walk of length of 5. Okay, now again this is a walk definition. Now again some definition. A walk which no vertex appears more than once is called path. More than once. Vertices only appears one time. Okay, here PQR, this is called path, but here you see that S is 2 times. S vertices is here is a 2 times. Okay, so this is no we do not call this as a path. Okay, so definition of path is no vertex appears more than once. Okay, they have also given PTSR is also a path. Okay, a walk of the form QSTQ now, which has no vertex appears more than once except for the beginning and end vertices. Okay, beginning and end vertices which coincide, it's called a cycle. Okay, so they have started from the Q and again ending their walk with the Q. We have started from the home and again ending with our home shopping after shopping. Okay, so this is called a cycle. Okay, so here in this paragraph we have learned three definitions. A walk, only we have to go from one vertex to another vertex. Okay, which have no any condition. Okay, simply one vertex to another vertex. But path is, it's called no vertex appears more than once. Okay, vertex has to only appear for the one time. Okay, and then cycle, no vertex appear from more than once except beginning and end. Okay, in between no vertex appears has to more than once. Like say, if I say P Q S T Q and again P, this is we can say that we have started with P then ending with P, but this is not called a cycle. Why? Because Q have we have get to Q two times. Okay, so in cycle two condition, beginning and ending vertices are the same and no vertex appears more than once, it's called cycle. Okay, so walk, path and cycle. Okay, okay, next definition. Okay, a graph and diagrams containing walks that include every edge exactly once. Okay, every edge exactly once and end back at the initial vertex. Okay, started with the vertex and end back with the initial vertex like cycle. So such graphs are graph and diagrams are called Eulerian graph. Okay, next types of graph is called Eulerian. What this say, that edges are come with all the edges are connected and edges exactly once. Okay, they have to include every edge and edges come to exactly once and add back with the initial vertex. Such graph are called Eulerian graph. Okay, here our this figure is not a Eulerian graph. Why? Because let's say start with our P point. We have to go from P to Q, Q to T, T to S, S to Q, Q to R and R to S. And again S to P and P to Q, T, S, Q, R, S, T and here you can see that we have started with P but not ending with P. We have end with T. Any path you can choose. Okay, let's say we have choose from P S T Q, P S Q T, then T S R Q P and again P. We have to add every edge and every edge one time, only one time. We cannot go from T to Q and again P, and we have to start from P and ending with P. So then we can say that this is Eulerian graph. So this is not a Eulerian graph. Okay, you can get the idea how Eulerian graph is definition of Eulerian graph. Okay, we have to include every edge exactly once and end back at the initial vertex. Such graph are called Eulerian. So our previous graph is not an Eulerian. Okay, so they have started with P and ending with T. Okay, so this is ending with different vertex from the initial one, so it's not called Eulerian. Okay, and next definition is graph and diagraph containing cycle that passes through every vertex. These are called Hamiltonian. Okay, they have passes with every vertex. Okay, So here again our graph, let's say P, Q, T, S and R. Okay, P, Q, T, S and R. Okay, so they have passed with every 5 vertex. Yes, yes. So this is called Hamiltonian graph. Hamiltonian graph. Okay, so the Eulerian have 3 condition and Hamiltonian have 1 condition. Okay, and also have to complete with the starting point and ending point. Okay, so suitable cycle is P, Q, R, S, T and P. Okay, so we have discussed here definition of 2 gram. Okay, so now in this lecture we have discussed a number of definition like Hamiltonian graph, Eulerian graph. Here 3 definition: walk, path and cycle. Then simple graph and directed graph, and directed graph edges is called arc. Then multiple edges and loop. Then vertices, edges, it's called graph, and the degree of vertex. Okay, so this is we have studied till now. Okay, now we will see this in next lecture, but you have to complete your assignment of point 1 and point 2. Okay, you do not have to calculate this. Okay, so write down the number of vertex, number of edges and degree of each vertex, for this figure and this figure also. Okay, so this is your assignment question. You have to write down and upload it in the RNWIET application. Okay, now your lecture is completed.